So, alright guys, hello guys. Today I'm gonna show daily Leetcode question. Hello guys. So today I'm solving daily Leetcode question. Closest prime number in range. So the question will give two positive integers left and right. We need to find the num1 and num2 such as uh, that two numbers are in range of left and right, and num1 must be less than num2. So both of num1 and num2 must be the prime numbers. So we need to find the minimum pairs of distance of two numbers that. So we need to find the minimum distance of two numbers. For example, here, if left and 10 and right and 19, we have the four prime number. The first one is 11. The second one is 13 and 17, and then 19. So the distance of 11 and 13 is about 2. So distance of 13 and 17 is 4, and the 17 and the 19 is 2. So that means we choose the first one is the first pair one is about 11 and the 13, because it's the mean distance about 2. So also we have left 4 and right 6, but in range of that we just have the find. The phi is the prime number. That means we do not create any pairs, so we need to return array of -1. So that's basically the question, but we need to attachly that the constraint about the left and right will be grow to the 10 power 6. That means you need to do the algorithm to be about O and log n. Yeah. So we think that, for example, we need to find the price number. We look through that. So let's brainstorm about the solution. The first thing that we try the brute force solution. So we find the prime integer in the range by loop through that. So that will cost about O(n) is less than, yeah, it's O(n), the cost is O(n). No, first step we check loop through we loop through O(n) for loop through for range, and we need to check is prime by doing the algorithms about we loop to the 2 to the n number. That means the time complexity will be O(n) squared for checking that. Or we can check the is prime in O square root n, the first one will be checked by C. That will be cost about sip of error thought. Error thought is about O n log n. So in here we just look through that. We look in n 2 to n and check that if we just have the divided by 1 divided by if n divided by any number in here, we will return false because the prime number that just have the divided by 1 and itself. So that means if in range of we divided by range of 2 and n, that will be false. So we also have the 2 and square root of n, and the time complexity will be O and square root. So we just look to the square root, for example. And also we have the sieve of error thoughts is the time complexity n log n. We assume that will be cause the overall time complexity will be O(n) squared, that not pass the test K, not pass. And here we just O(n) squared. And so let's check that is about 10 power of 3 is about 10 power of 9. So in this row we need the time complexity will need be O log n. So that means that also not pass. And here will be pass. Because we check that is O(n) and we plus for log and power 6 is about, I think it's about less than, so I think it is that will pass. So if you don't know C error type, so you can search in Google. That basically we look through that we create the array in range of n, the map left and right, and we define that its prime 0 and its prime 1 will be always false. And we look through that we start with p equal to 2, and for any p power 2 less than n, we check that it is prime. If it is, we look through, we look through from p number 2 to the n, and each of it will be distant is p, and if we said that it's primary false, and then p plus 1. So we can see that sieve of error code we can see that here the first one is 2 and 4, 6, the multiple by p, the multiple of p, 2 and 4 and 6 and 8 and 10 is multiple of 2, also 3, 9, 12, 15, 18 and also multiple 3, so on and so forth. That means you can create the list of prime number in n-log n time. So that is, I think that is most optimized to check is prime or not. So yeah, I also show the code here. So thank you for your watching.